be like, for this section, we will go and continue with the continuous probability distribution. And I provide for your the PowerPoint slide, also for the demonstration of everything calculation on Excel generated on YouTube. Okay, so you guys can easily come and go back like that. And like always, if later when we finish the class, I will generate for the week number 5 full class video. So in case like some student they could not attend in our class, they can take a look and to see the playback. I also provide in here very important, that will be normal distribution curve generation link. You will learn how to do it like right after that, and I show you how to do it, but that's very simple. You don't have to worry. Click on and they will generate for you, and you can feel like everything will be very easy in this class thanks to this all. Okay, and another one that will be in this week, we don't have the data sets. We practice it just like in solely one single video Excel, and we do for the quiz number 5. This week we don't have any assignment. Next week will be the next assignment. Next week the homework number 2 of the group assignment will appear, and you guys will have to do it. But believe me, that will be very easy. This week I will just change the highlight the due date of this one. Okay. So it's going to become available right on the Tuesday. Okay, November 2, and to everybody's, and this could be due on like next Sunday 31, but you'll be open until like the November 1st. Okay, that should be my messages for you guys. All right, and another thing would be like the quiz has been available. Okay, another thing will be like this will be the PowerPoint slide, and that's will be quite a short, which is about 38 slide and even less, because I'm going to apply some kinds of trick so you guys can apply it and can save the time when you do all the calculation on the Excel. Okay, you can download it on, you have the video here, you have the link to do all the calculation over here. That will be fine, and just have the quiz in this week, so it's quite easy in this week. Okay, now let's continue and let's just start for the main section of the today. So you guys, continuous probability distribution, and we already learned in the last week, right? What we call the discrete probability distribution, and the today's section will about the continuous probability distribution. That's another branch of the previous compared to the previous discrete one. Okay, so for example, in the last week we learned already about the binomial distribution and partial probability distribution, and we talk about the two different ones. The discrete random variable that had the finite number of values or infinite sequence of values. Today's section we talk about the continuous random variable that have any numerical value in an interval or a collection of intervals. You will just continue with that, and you will just learn about the probabilities of the uniform and the normal distribution. Especially the normal distribution will be our main theme. Based on this one, later, even like later, every chapters of this section of the class of this class, statistic and foundation of the business analysis. Sorry. That would be all based on the normal distribution, and you have to be very careful and you have to study in depth. Okay, but don't worry, you will just take a look and see it like all the time like that. Okay, all right, now let's talk a little bit about the introduction and some assumption about that. But I believe me, like for this session, we could just make it very kind of easy. You had just like all the things, you had to just learn and understand about the main concept of the normal distribution, and you just have to apply it in the later chapters. For example, in the sampling and sampling distribution class, that will be the thing of the next class, and later will be the interval estimation for the next 2 weeks, and then later for the hypothesis. All the things like that, they will be based on the continuous probability distribution, specifically that will be normal distribution. Okay, so like last week I already mentioned, okay, the continuous random variable can assume any values in an interval, okay, in an interval or a collection of interval. And remember about that. Anyone can give me a highlight. Sorry. Anyone can give me a guideline, an example about the continuous random variable? Remember about what I say about last week? Anyone?
Weight.
Weight. Yeah, that's good. Right. Weight. So why you say like weight will be continuous? Okay. Continuous random variable. Why? Weight, right? You say about weight. Why you think they would be a continuous random variable? Yeah.
Yes. So I think because when we measure weight, they can give you a lot of result. Maybe when we measure kilogram, they can 5 kilogram, 5.8, 6.9, yes, and
5.8,
yeah,
6.9, and even like 6.91, right? Or
yeah,
even 6.915. Okay, they will be all continuous like values in an interval. For example, like the lower limits will be 5 kilogram, and the upper limit is about like 500 kilograms. So between that, you can get any kinds of value between this one. Okay. Thank you a lot, Long Nhật. Like one extra credit for you, okay? Remember about, tell me about that in the end of this class. Okay, so it's not possible to talk about the probability of a random variable assuming in a particular values. The thing would be like, if you really do it, and for example, you have up to about 10,000 guy, okay? 10,000 guy, and they ask about like they weight, okay, like they weighs about like in total they make it up to n, okay, number of the number of the observation will be 10,000 guy have been asked, and the weights for the minimum, some of them will be about like 20 kilogram, maybe that's a very small kid, and when the other they can be 20.1, another will be 20.12, another one will be 20.1, 71, okay, and the same thing like 21 and 21.5 and blah 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 blah. Now blah 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 blah, okay, blah 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 blah, okay, for example here, okay, and the same thing blah 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 blah, okay, blah, okay, and up until here like about like 190 kilogram, 191.5 kilograms, something like that. So they say like it's not possible to talk about a probability of a random variable assuming a particular value. So when we say about like, if you really think about the weight of the guy can be like 21 kilogram. among 1,000, like 10,000 guy, maybe just one single guy, right? If that's going to be a frequency, okay? So if that's a frequency, so maybe just have only one single guy have the weight of about 21 kilogram, right? And maybe in like about 50.2, there's just about two guys among like 1,000 of them. And if you really wanted to measure for the calculation about the probability like that, and you divide for the total number of the observation, okay, they will be super small. They even like you cannot display them like even in percentage, like 0.01 percentage. They almost like impossible to demonstrate about anything about one single value. Okay. Instead, we talk about the probability of a random variable by a given interval. So for example, if I do it and if I really want to make something clear about the measurement about something like more meaningful, I will have to just do it one more time. But I have to create for an interval. Okay, in interval. Interval tức là một cái khoảng. Okay, giống như chuyện mình chia khoảng vậy thôi. Lần trước thầy có nói không? Remember about that? Remember about that? Okay. So we have to make it like interval. Instead of that, I say like 21 into like 25 kilogram, okay? And then I make about 25 into like 30 kilogram and the same like that. And frequency now when I add up for very long, a lot of the value like that, a lot of kind of separated value like that, they can make it up to like 150, maybe 50, 150 guy before between like 20 and 25 kilogram. And that could be what we're going to do, okay? And you see like about 0.5%. That should be in this interval, okay? Cái đoạn này thì mọi người hiểu ý thầy nói là gì không? Mọi người. Đối với các giá trị trong cái phần mà continuous variable này thì mình tính từng cái giá trị, bởi vì đây là những cái continuous variable nên nếu mình tính từng cái giá trị á thì gần như là probability của từng cái điểm này nó rất là nhỏ, nó gần như coi là 0% luôn. Đây là may là ví dụ mình có tổng cộng là có 10.000 người đó, lỡ ví dụ như mà mình có 100.000 người và 1 triệu người chẳng hạn, thì gần như những con số này nó không có ý nghĩa luôn. Các bạn tính đã đời cho nữa nó không có ý nghĩa mấy trơn. Thấy không? Đó, cho nên cách duy nhất là người ta phải tạo thành các interval để mà người ta tính luôn probability luôn trong một cái đoạn giá trị. Okay, and that's what we're going to talk about. And the probability of a random variable we will just measure the value within some given interval from x1 into x2. For example, this could be uniform random variable, and we want to continue to calculate. Maybe they can like demonstrate for spread between like about 5 into 15, and we want to understand about probability that your value will be between like about 9 into 10, something like that. So that will be how we measure, and we define it all. Like people very smart, man, and they don't do it with the previous class about. We talk about the discrete variable. They don't do something like this. They don't do it very stupid like this. No, they no longer do that because that all the values now will be continuous, and they can generate it and calculate everything in terms of geometric hình học, and they do it in the calculation of very simple calculation before. For example, in the uniform, you see like all the distribution, it look like the same with the rectangle, right? This look like rectangle or the square, and they measure it by all the formula to calculate for the areas of the rectangle, and that's very simple. And the same with the normal distribution, they will be a little bit harder, and they do it with the antiderivative calculation. But however, the calculation on Excel and calculation on the kind of scientific calculators and online website they can measure everything for you. So you can measure like this, okay? This is the same. For example, uniform, I told you already, right? If you want to just measure for the two continuous values between like 5 and 15, and you want to calculate for the areas between like 9 into 10, you can welcome to do that. And the same thing with the normal distribution. Maybe the distribution will be spread from like this will be 0 into 10, and you want to measure the probabilities or the area between maybe 7 and 8, okay? And you can calculate it all right? So that's what the people say, the probability densities function, okay? The probability density function, that's be what the people going to just measure, and this will be what we're going to just illustrate in the two different functions. The first of all, the uniform distribution, and another one, the normal distribution. Okay, so first we come with the uniform distribution, and this will be very easy to understand. I hope so. So the uniform distribution will have the same probability for all the proportional of the interval length. Okay, so the uniform will have the function will be the density function of x will equal to 1 divided for b minus a, where b will be the largest values and a will be the smallest values. Okay, let's just remember about this function. Okay, and we gonna just do it right now on Excel, and you can see how it will work. Like for example now, and this will be the expected value. Okay, and I will demonstrate for you why it is. Okay, the expected value. Okay, now let's continue, and I demonstrate for you to understand about what exactly it could be. So first of all, we talk about an example. All right, the settlers customer are charged. Sorry, I believe that in some case, like it's better for us to just demonstrate it on my tablet. This would be easier. Okay, so the settlers customer had charged for the amount of salad they take, assuming sampling suggests that the amount of salad taken is a uniform distributed between like 5 ounce and 15 ounce. Okay, 5 ounce and 15 ounce. Okay, so if we're really gonna do it, how can we demonstrate for that one? Okay, let's wait. Just wait for a second. I will just demonstrate it on my computer, my tablet, so you can easily see it. Okay. Okay. So you got it? You got the screen? All right. So the customer. Okay. So the customers, I will just demonstrate it on another computer. Okay. Okay. Yep. Missed me. Okay. Now let's do it. This will be the distribution. Okay. Remember about the function of the uniform. Probability distribution. Okay. And now there, remember the function. That will be the example. So example, you go into a restaurant. Okay. A restaurant. Okay. And you go and just spend for something about in the dish. So you come there and you eat it, right? This. So suggest the amount of the salad taken. So you put into here some salads, right? Sorry about that if I make it very kind of ugly about my handwriting, sorry. Okay, so put it, then you put it into the dish, and then you go into put them into a scale là cái cân, right? And you see like how it could be in terms of the weights of this, okay, the weights of salads. So the more you eat in the salads, the more you have to pay, right? Something like that. Okay, and now they say like all the things they will be uniformly distributed between 5 to 15 ounces. Okay. 5 to 15 ounces. Okay. So that's what we're going to talk about. And how we demonstrate for that, man. How we demonstrate for that. So remember about everything. They are normally uniformly distributed. Okay. And this will be the x values, and this will be the density function. That's what we say, the density function. Okay, and we generate for some kinds of graph like that. So this will be 0, like in like ounce, right? X will be actually that will be the weights of the salads that we put into our weight of salads. Okay, that we put into our this, okay, our plate. And so they will be uniformly distributed between 5 and 15. Right? Between 5 and 15, right? So all the data, remember, all the data, they will be just fluctuate between this much, right? This much amounts of the weights, okay? And now let's come back and remember about what could be uniform density distribution. So they will be Fx will equal to 2Ks. So first of all, they will be 1 divided for B minus A. In case like X will fall between like 5 into 15, remember? And that will be equal to 0 if X will be not belong to 5 to 15. Remember about this one? This will be the function, okay? So now anyone can measure it for me? What will be A? What will be B according to this function? Mấy cái phần này rất là dễ, giống như toán. Okay, Hương Ly.
So A is equal to the smallest value is 5 and B is the largest value is 15. So we have Fx equal to 1 over 15 minus 5 is 0.1.
Okay, 1/10 or 0.1, right? Or 1%, right? So I will put it like 0.1 here. This will be 0.2, but of course not. So we have the same probabilities, right? At here, at here, at here. So if we do it like for everywhere, between this interval between 5 and 15, we have the same probability for everywhere, right? You understand? You got it? Okay. And if that belongs to 0, if the like X will be not between 5 and 15, like for example, if you ask me about like what happened if X will be equal to like 17, what I'm gonna say? This will be equal to
0.
0. Yeah, that's right. Okay, you got it? Right. The same thing. If I ask for like about X equal to about like 2, there will be 0 probability. No, there could no way that they could belong to that one. Okay. Right. Now, let's continue and then talk about if I ask you, okay, if I ask you, what will be the probabilities for between like, for example, 8 to 10? How can we measure it? Thank you, Hương Ly. Okay, I give you one extra credit, okay? Right. So they will belong between 8, right, and 10. And this should be the area, the areas. Thus, we going to measure for, right? This will be it. And how we measure for that? Very simple. Just think about they the same with a kind like what? A rectangle, right? Một cái hình chữ nhật, right? How we measure for this probability? They will equal to this side and time for this side, right? 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 The width and the length, right? Okay, so the width, okay. Okay, the width time for the length, okay. If you really want me to just put everything like in the simple way like this. So the width will be how much? They will be between 10 and 8. That's be 2, right? Time for the length will be 0.1. Okay, so 2 times for 0.1, that's equal to 0.2. Is that hard, man? Is that hard? Anyone feel like it's so crazy? No, right? I hope so. Okay, another thing. So another thing, like we going to just measure like the same to every other types of the density function. We have to calculate for the expected values. Okay, expected value, that means like the value that has the highest probabilities of x. Okay, so it's simple. The expected values according to what they say, that should be ax, and anyone can measure for me. That's equal to what? Lee, just Lee, nobody else. Okay, expected value equal to Lee, please.
So the expected value is equal to 5 plus 15 over 2.
So A plus B, right?
Oh, yes.
So that means 5 plus 15 divided for 2, so that will be 10. Okay, so if you really want to talk about what exactly the expected value mean, the expected value symbolize would be just the value in the middle of everything, right? The value in the middle of everything. So you see over here, 50% of all the probability, and this will be the 50% of all the probabilities. Later, when we talk about another function, okay, so the same. The expected value will be over here, and that divide for the values all the area, okay, the area, all the areas into the two different separated, and they all 50% and they all 50% symmetrically. Okay, but then let's talk about that later. That's very easy. Okay, and the variance. Okay, anyone want to measure for the variance for me? The variance of x, Hương Ly.
So the variance of x is equal to b minus, no, the square root of b minus a over
square over 12, okay? And that's equal to?
It's equal to 25 over 3.
And that should be 15 minus 4, 5, right?
Yeah.
12. So equal to 100 divided for 12, that should be 8.3 something. 8. Okay. Right, so any question about this one?
Thầy cho em hỏi chút cái chỗ probability của cái 8 tới 10 thầy.
Ok.
Ví dụ mình áp dụng cái function fx vô thì nó lại khác đó thầy.
Function fx vô là sao em hả? Ấy là function fx vô là làm sao mà fx vô không phải fx vô tức là cái giá trị function, giá trị bằng của tất cả các giá trị này. Mọi người nhớ không? Nó không phải là fx là để tính cho giá trị, đây là x một giá trị cụ thể, ví dụ giá trị như bằng 5 rồi đó. Mọi người nhớ được không? Đó, chứ không phải là fx này là nằm cho từ 8 tới 10. Mọi người hiểu không? Ví dụ như giá trị từ 8 tới 10 là tính khác. Còn fx này là chỉ giá trị để mà biết được cái giá trị ở một cái đường ngang này này. Fx của nó luôn là bằng, ví dụ như đây nhiêu đây.
Cảm ơn.
Rồi, ok. Alright. Mọi người có thấy khó khăn dưới đoạn này không? Thầy gần như thấy không có cái chuyện gì mà phải nói gì về cái phần mà gọi là probabilities của cái phần này trong hết đâu. Rồi tương tự như vậy làm thử lần nữa hãy. Ví dụ như ai tính được cho thầy. Cảm ơn Ly, hãy Ly cộng cho Ly thêm một điểm này. Ok. Ai tính được cho thầy một cái khác hãy câu. For example, the example 2. The probabilities of the place will be between maybe 12 into 15. Okay. According to the book. How can we measure it? So from 12 may be over here, right? And 15 over here, right? They asked us to measure for this area. How we measure for that? Ok, Long Nhật Ly rồi. Ok, Long Nhật đi. Long Nhật để Long Nhật có điểm.
Yes, so we calculate rectangle of 12 and 15. Wide of the rectangle that is 3 multiple the length that is 0.1, so equal 0.3.
Okay, so 30%, right?
Yes.
That's all you can say. What if you say it in the word? So what you gonna say is that? Nếu như mà diễn giải nó ra thì mọi người nói như thế nào? There is 30%.
Happen.
30% of probability that the weights of the disk will be between 12 and 15, right? There's 30%, that's the weights of the disk will be about between 12 and 13. And the same thing if I apply for that one, right? I ask for like this just long between like 5 and 15, and I ask about like the probabilities, that's 0, 1, and I ask about like what would be the probabilities between like 8 into like 13, right? So 8 over here and 13 over here, and when I measure that, that will be like 0.1 times 4, 5. So that's 50%. So I can say like there about 50% that the weights of the disk will be between 8 and 13. Okay. All right. You got it all? Any question? Any problem? Any problem? Okay. And would be okay. I stopped sharing from my screen over here because it's quite easy now. Stop presenting. Okay. And let's go back into the screen. Okay, so if some of you guys really wonder why, and you feel like I'm curious about why the expected value is quite easy to understand, right? There will be just the middle point of the minimum value and the maximum values. But for the variance, they quite hard to understand why that will be the minus between the large and the smallest values square and then divide for 12. So if you really wonder about why exactly they come from, I would just recommend you guys to just learn more about in the linear algebra and about the advanced about the advance of the giải tích. Tự nhiên thầy quên giải tích nó nghĩa là chi trong tiếng Việt, trong tiếng Anh nó tên thời chữ gì đó. But however, antiderivative, they will measure for, they provide for all the function about how to do all the calculation about the variance. You are welcome to just go back, and if you really want to understand about why, that will be a function of quite hard to understand, but you will be all the time will be measured on that way, and welcome to do it all. So they base all the thing on the moment generation function, and they do it all based on the calculation of, I don't know how to just represent you guys, calculate for the just a spinning function, and they quite complicated, and that's the reason why I didn't want to spend too much time for you to understand about this kind of variant. Okay, so if you really want to care about that, you can just welcome and go back into, and over time, anytime you can go into some kind of website, and they can represent for you guys about how they measure for the variant, the function of the variant of the uniform probability distribution. But it could be quite more mathematical focus, and that's out of the scope of this class. So I don't want you guys to spend too much time on that one. Okay. All right. That's very simple. For the first one, the uniform probability distribution. And this will be the second part. Okay. Hey, I did really hate this one. Okay, the areas at the measure of the probabilities, and you already see that how I did it with the uniform distribution, right? I do it like making all the measurement just based on the same ways that I do with the calculation for the function of how we can measure for the area, the areas of a kind of like a rectangle, right? The same, I just measure it by time for the length and the width. But however, with the same philosophy, with the same faction, they can apply it in measure for the probabilities, because the people in any way they believe that all the distribution, if they put them like what the people call the area under the curve, okay, the area under the curve, they will be all in summarize equal to 100%. Okay, and the area under the graph or area under the curve can be measured like a kind of like alternative, like they are totally identical or the same with the probability calculation. So when you don't really have to measure for the probability, but with the continuous random variable, you have to just all the thing you do with just measure for the area under the curve, and that will be enough. Okay, so that will be good for all the continuous random variable, and the probabilities when you really want to measure between the x1, the lower values, and the x2, the higher values, will be measured. For example, x1 here will be 0, right? That equal to 0, and x2 that will be equal to 1. So x1 and x2 that will be the lower and the higher values of the interval, and you can easily compute for the area under the curve for the interval between like 0 and 1, or between x1 and x2. And I will show you how to measure it all, but basically understand in this section, in this slide, that's just make you think about like measure the probabilities, the same with measuring the area, the same with geometric function. Okay, so we talk about now it's no longer could be the uniform probability distribution. When you have the same probabilities for all the values, they have quite the same with the values in the low values, and the same with the probability for the high values, and the same with the probability in the middle values. But however, when we talk about the normal distribution like this one, right? You just think about like just spread from the minimum values like about 0 into the maximum values like about 100. You can see that most of the time, most of the probabilities or the most of the frequency of the data, they will be generated and be concentrated in the middle, right? In the middle values. However, in terms of the very small values and in terms of the very big values, they are not so popular. Just very few of them will be have a very small and very big values, okay, in the function. Right. And that's what we say the normal distribution. That will be one of the most important distribution in this section. They will apply further in the statistical inference. Statistical inference, we'll be talking about the sampling, about sampling distribution. We learn in next week. About the interval estimation, we learn in the week number 7. About the hypothesis testing, we learn in the week number 9. And even for the other function like for the regression model in the week number 10 and 11, you all learn about the normal distribution. Okay, so you can see they will be have the wide variety in the application in the real life. For example, the haze of the people, right? Thinking about the haze of the people, most of the guy in Vietnam, right? There is just around like 1,5 tới 1,7, something like that, or 1,75, something. Okay, to from like 1.5 meters into like 1.75 meters, something like that. And you see like very a few of the people in Vietnam, they have the hazes around like just 1 meter, cao có 1 mét, or like 1.5 meter. I'm talking about the adult, right? I'm talking about the people who are already mature. So in that case, they all of them will be quieter. Not a lot of them will be very low, and not a lot of them will be very high. Okay, not a lot of them are higher than about 2 meter, right? Not, I believe that in Latvia and UK, we don't have the guy who are higher than 2 meter. Okay, so that's what the people say about the application of the normal distribution. They demonstrate about most of the distribution of the variable in the world, about the haze of the people, about the ways of the people, about the test score when you do it like in the, if you really want to see it. And last time I already demonstrate for you about the test score, right? The test score of the Vietnamese student. If you really want to see it, the test score. Okay. Distribution. The test score distribution for the maybe the IELTS. If you all know about that, sorry. IELTS test score. Okay, and I want to see some image. And this could be what the people normally do for the IELTS, right? That's what they say about the IELTS score, and let's go and check it. And this will be the distribution of the IELTS score and percentage of the mainland China. The mainland China, even they not perfectly be normal distributed, but for in the mainland China, this will be the what we say the China, right? Tàu khựa, something, whatever that you say. Okay, fine. But for the people in the mainland of the China, like in Shanghai, like in Beijing, like in like Xianchang, like in Shenzhen, they will be all be calculated and they distributed in this function. And you see, like most of the guy, how much they score, guy? How much they score for most of the guy? Anyone see it? Lee or Nhật or whatever. Just a funny question.
Yeah, I think that from 5 to 7.
5 to 7. Yeah, most of the guy will be about 5 to 7 or something like that, right? And that really makes sense. And that's even true with us, right? The Vietnamese So we said the same. All this most of the time you guys do it. Very few of you guys, if you really take the IELTS exam, right? You spend for more than about 4.6 million dong, right? And you don't really want to just take like 4 or 4.5 below 4. No, just very few of this guy. I never see anyone who ever make it like about 3 in my life. Of course, there's some people available there, but with me, I would say like no, I never see anyone who really make it like about 3 in the IELTS score. And I met several like they make about A's, they make about like 8.5 or they make about like 9 in the IELTS exam, but just very few of them. Up until now, I just know only one guy making like 9. That's a Vietnamese, and about 8.5 several of them like my friend, something like that. Anyway, like, I never have to take the IELTS exam anymore because I'm graduated from U.S. institutes, and they will reward me for all the kind of elite proficiency evidence. So of course I have up to like 2 master degrees, no longer to have to deal with that. Okay, and the same with the test score, right? And remember about the last time I talked about the điểm thi điểm thi Trung học phổ thông 2020 2021, right? And if you remember about that, all the score distributed is the same. Okay, this is right skill, but they still be follow the normal distribution something. Remember about this one, remember about the môn ngữ văn, môn toán, môn tiếng Anh, right? Remember about the địa lý, lịch sử, something like that. They will follow the normal distribution. The amount of rainfall, lượng mưa, scientific measurement, all the things like that. So thanks to the Abraham de Moy, the French mathematician, and he was a very old guy back to the time of the 17th century, something like that. But he derived about, he put all the theories, he developed all the theories about the normal distribution, and we had to think about that. So based on that one, his work about normal distribution, we learn about how to make all the thing about probabilities, and that's really fantastic. And you have to say thank you about him, okay? That's about normal distribution, and we all will talk about that later, and about how do we measure that, how we can demonstrate it, and how different is how to measure that, and doing about the standard normal distribution, normalization. We'll talk about that later in the next session of the class. So we take a break in about 5 minutes. Is that okay? Okay, guys, let's come back. All right, let's just come back, okay? And now we talk in detail about the normal distribution, and this will be the function of the normal distribution after we already know about the application, right? They will be most of the time the most popular, most well-known, and most kind of popular and easy to see in most of the distribution of the word. And this is the function. You actually don't have to remember about the function. And even very long ago when I studied for that, I never can remember that because I that long function about the normal distribution. Basically, the sigma this will be standard deviation of the data. Mean values mu, this will be the mean value if you measure for that. And p, you know about p, right? And e, this will be the exponential of the natural log. Okay, right. And just you don't have to, one more time I have to say, you don't have to remember about this one, okay? Just try to understand about what exactly they mean, okay? Right, now, the normal distribution, we will see like distribution of the normal distribution could be symmetric, and I already know. They will be the skewness when you measure that, you be 0, they will be not the positive, they will not the negative of the skewness, okay? If you really understand about that one. And the distribution using matrix, that means we can divide the data into the different part, and they totally will be the same between the right tail, and the left tail. Okay, all right. So characteristic of the normal distribution, we just care about the mean value. Sometimes they say it could be mu, sometimes they say it will be m. That will be fine. Standard deviation, okay. Standard deviation and the mean will be the two parameters of the normal distribution. When I talk about a normal distribution, for example, I say a normal distribution. You will have to tell them about the mean value and another one standard deviation, and you can see how they change. Okay, so for example, one more time, let's go and just use for the function over here. Okay, you can use the normal distribution curve generation link. You open it on, and they will be, yeah, they will be not kind of directly or display on canvas. So you click on the kind of the white link over here, and they will just list you into the homepage of the Division of Statistics and Actual Science of University of Iowa in the US. And thank you for the Mark Bonner, the one of the kind of famous statistician in the world. And the only thing you have to do would be like put into the normal distribution. So normal distribution here, they will help you to measure and just generate for the function. It look like this, and the thing could be, yeah, you have to put into the number to modify the values. So for example, over here I put in the standard, the mu, that means the mean value of the distribution. For example, 50 kilogram. Okay, we talk about the weights of the people in Vietnam, and that should be 50 kilogram. And the standard deviation, I put in about like, let me think, 5 kilogram. Okay, and this will be how it generated. You see, like most of the data, according to the calculation. So most of the people will be from like 40 kilogram into 60 kilogram. Okay, this will be for maybe lady. Okay, actually that's be more suitable for lady, and very few of them will be make it very low. Very few of the lady can weigh around like 30, and very few of them can weigh around like about 70, and that will be the point of the data. Okay, now let's do it with one more time, and let's can do it. And you see, like if they're symmetric and the data itself, it can distribute it according to the normal distribution. You guys hear me clearly, guys?
Yes, teacher.
Yes.
Okay, yeah. If you see, that will be normal distribution. So you can see this is the mean value. Okay, but at the same time, the mean value will be the one have the highest probabilities. The mean value also will be the median values, because they will be larger than 50% of the data and smaller than 50% of the data. And this mean value will be also the most, right? Because they have the highest probability. That means they have a highest frequencies of appearance. Okay, so in a normal distribution, the mean value will equal to the median value and will equal to the most value. Okay, they all have the same value. Okay, right, now let's get to it. And the mean values, they can be different. Like actually when you say about because we had the two different characteristics of the normal distribution, right? The mean value and the standard deviation. So we can see like how they different in the different mean, and we can see how they different if they had the different standard deviation, right? Oh, what happened? Okay, so the mean illustration, and we see like how they're different in the mean value. Okay, so how the different mean value it would be. We have the different mean value over here. Okay, you see how they generate. You can have the data like we have the mean value of the normal distribution be about 25, but sometimes normal distribution can be just around like 10, like sorry 0. This will be have the same, and with the mean value could be like -10. So they just kind of like move along between the value line, but they have the same shape, of the curve. Okay, the same thing when I go and just generate over here. Okay, I keep the same standard deviation, but I change for the mean values. So if I put it like 0, you can see over here most of the data fluctuate between like -20 into 20. So from 0, that should be the mean values. They will fluctuate between 20 values, right? From 0 into 20, from 0 into -20. That could be the point. I still keep the same with the standard deviation like 5. I change it like about 100. What happened now? Now they have the different mean values, right? 100 will be the new mean values. But however, when I talk about how they fluctuate, the mean values, they'll be 80. The maximum values around like 120. So it look like the data still fluctuate 20 between the data, between the mean value, okay? Between the mean value, I minus 20, that should be 80. I plot for 20, that should be 120. The same with the 0, right? I still minus 20, I still plot 20. And even I change it right now, it's like minus 200. You can see it minus 200 could be the mean values. And the minimum values, they surround like minus 200. And then we minus for 20. So minus 220 and minus 180. So they had different mean, but with the same standard deviation, they still have the same shape. Okay, you got that point? I got it. Not so hard, right? Now, if I still keep the same with 0, but if I change for the standard deviation, how they will look like? Okay, up until now, everything will be put into like 5, right, with the standard deviation, and I change it now with the into like 20, and you see like the mean value is still the same with 0, but now the standard deviation, they fluctuate very large from like minus 75 to 75 something. Let's check it with another one, like with 30. Oh, they even spread with the larger spread of the values. Okay, larger spread of the values. Okay, and if I just make it spread small, like just 1, now around 1, they just fluctuate between like this, from minus 4 into 4. I put it like 0.5, they're even smaller. Okay, so in this case, I stay the same with the mean values, but I change for the standard deviation, and they have to be changed. And in this case, that will be there. When we change the standard deviation, they determine for the width of the curve. You can see how large the result will be wide. The larger the standard deviation, the wider and flatter the curve will be. You see over here, if for example, I take the standard deviation of 15. So the curve will look like this. They will have a kind of a sharp and they quite a steep. But however, when I change the standard deviation, I still keep the same mean, right? But I change the standard deviation into 25. Now they flatter and they wider. Okay, the mean values, math values, it look like wider than the previous one. That's the reason why I want to demonstrate for you guys to understand about the two characteristics of a normal distribution based on this function. You guys are welcome to just go back, use the mic link, and you can create for the normal distribution according to what you want to do. Okay, right now, if you really already understand about the normal distribution, of course, all the areas, the total area under the curve, that means all the probabilities That's all the value of the function will be equal to 1 or 100%. That makes sense. And 50% will be allocated in the left side, and the 50% will be allocated in the right side. And that's really makes sense because that all the data will be just have been demonstrated for a kind of like a symmetry. That means the data is symmetric. Okay, that would be the way for us to think about. One more time, the idea about normal distribution with the empirical rules. And that's what I already tell you last time in the section number 3, okay, about the numerical of the measure of the statistical the descriptive statistic. So remember about that one. If between the mean values and I add in into 1 and minus 1 the standard deviation, 68% of the data will be belong to that interval. If I increase for the y, and then I plus and minus for 2 standard deviation, all the data will occupy up to 95%. And 99.72 or almost all of the data will be belong to within pre-standard deviation. And this is what we already talked about, right? We already talked about this one. If you had the mean value, if you had the standard deviation. So if you plus 1 and minus 1, you remember about this one, okay? 68% of all the data belong to this part. 95% will belong to the 2 standard deviation minus and plus. And 99.72% will be just fluctuate between 3 standard deviation. And that will be what I say about the standard deviation normal distribution. You guys all clear about this part, right? And có gặp câu hỏi gì em có thắc mắc gì đoạn này không? Guys? Hey.
Yeah, okay.
Yeah, I hope so. That's gonna be clear about this part, because that's be one more time talk about the normal distribution and the empirical rules. So I think that's gonna be fine. Okay, now let's talk about standard normal distribution. Standard normal distribution will have the mean of 0 and standard deviation of 1. They will be called normal distribution, but in the standard form. Okay, standard form. And this will be look like this. They have the mean values equal to 0. They have the 1 equal to 1. Sorry, they have the kind of standard deviation sigma equal to 1. And how the people generate it, they would say the letter G's to use definition case for the standard normal distribution. And how the people do it, they will convert the standard normal distribution by the z-score. Why? Then they take like the real values minus for the mean values, and they divide for standard deviation, and that create a standard normal distribution. Now you will feel like it's not so good, and I don't understand what exactly that would be. I would demonstrate for you guys how to do it. Okay, now I demonstrate it on Excel. Okay, anyone suggest for me a data set last week? Okay, in last week of the chapter 3, and we had the week 3 assignment data sets. Which one had the highest, the most of the have a lot of observation? Something Queen City, right? The Queen City, right? Okay, the Queen City. Okay, and let's see about the expenditure benefit. Something about the they have up to 5,000 observation. That's a lot, man. That's a lot. That's a lot. Okay, let's do it. Now let me just like demonstrate for you about this standard deviation. of this normal distribution. Let's check if this one really is the normal distribution or not. Okay, so how you can do it? How you can measure for the standard deviation of that? Remember, how can we measure for the mean values? Average, right? We want to check for the mean value of this distribution. I want to see the distribution of a span leader. Okay, and I want to check for the mean values, and I want to check for the standard deviation. Okay, and how can I do it? With the mean values, I use what?
Average.
Average. Okay. From this, at E2 into E 5,428. Oh man, that's a lot of data. 5,000 observation. So the expenditure for each of the department in this city is around like let me just do it like make it like 121.95. That's mean values. Okay. Standard deviation STDEV.P, because this is the data of everything. That will be the data of the population. So I will put in like P. Okay. Right. And I have this. That could be, wow, a lot, man. This much. Okay, now let's do it and create for graph. Remember about the pivot chart and pivot table and how I generate it is all the time. Remember? Okay. That will be welcome. And I'm going to, oh my God, no. Design, analyze. No, this one. One more time, and I make it wrong. Okay. Yep, right. I score it down for the expenditure, and of course nobody will really want to see it because they very long. But remember about that. There's an the way for me to put into the. Sorry, for this one I always can group them, right? And now they should check me for like about something, and I put it in this way. Oh, it looked like very good with the 5 different groups, but there's still a lot. There's still very few of them. So how about I put them into 5? Increase for up to now 8 different groups, but they still not to merge with me. I want to say like about just 1. Okay. I have too many of them over here. Okay, different kinds of group, and I score it down into the values. Oh, what happened? Oh, this will be count the expenditure, and just very few like that. Oh, most of the data will be belong to this kinds of group. Oh, this look weird. Okay, let's do it. And one more time, I change it for like 1 group. No, it's like 1 more 0. Looks so bad. Group. Ew, they look so bad. This data it look bad man. Có đứa nào có cái tập data nào mà nó đẹp hơn nữa không? Hôm bữa có tập data nào nhìn đẹp không? Mấy đứa? Hôm bữa có đứa nào có tập data nào trong mấy cái tập data mấy đứa làm có tập nào đẹp không?
Shopper.
Okay, let's check for the shopper. Cái tập này nó không có normal distributed. Okay, amount span này. Okay. For the order amount span, the same thing, right? I'm going to insert it and go to the pivot chart and assistant worksheet, and I want to put it here. And one more time, and one more time. Let's just not. I put it into cow. Of course, like this really so weird, and I'm going to change it. Grouping and starting, and it look like this. Still not so good. I would change it into like 20. It look like this. Okay. Okay, so they a little bit look like right skew, and that'd be fine. I will just stop it here. I don't want to waste the time of you guys. So the format assist, and I want to stop this one. I want to change it. Format the assist. Oh no, not this one. Okay, data series, and I want to have the gap. No gap. Okay, this could be the what we say about the histogram. Okay, and this could be what normally we call about the mean value. Okay, that I want to measure for the mean values and the standard deviation. Okay, it's not really so a normal distribution, but I would just demonstrate for you how they change. The mean values now it will be average. Okay, and from here until here. Okay, 68. That's standard deviation. Just wait a second. I have a phone call. Okay. Okay, guys, sorry. I get a kind of phone call from Viện Nghiên cứu Khoa học và Nghiên cứu Phát triển Kinh tế Xã hội thành phố Đà Nẵng. Because in UK, we are going to have make a presentation about the circular economy in the next November 2nd. Yeah, it's kind of like that. So they asked us to just submit for the PowerPoint slide and make the presentation. Sorry for about the interruption, but that's very quick. Okay, standard deviation, right? STDEV, job P, right? Remember? And I'm going to measure for the mouse span. Okay. Okay, now that should be 30 something. Okay. Let's just now check it and how and why the people call it. Why the people call make it like about standard distribution. Okay. How can the people transfer the amount span but into the standard normal distribution? Okay, how the people measure and do it with the standard normal distribution based on the original data. So how the people convert it, and you can see how the graph will change in this way. Okay, I will show you later how they change in this way. But first of all, we will have to measure it first. So we do it by use the function, very easy. Okay, let's do it, use the function like this f2, and then you do it like x will be the x2. And the mean values, you will be minus for the mean value, right? Mean values will be this one, J18, and divide for the standard deviation, okay? F4, okay. Right now, you got it here? And this will be the standard deviation. I'm sorry, the standard normal distribution data. So the data now has been transferred into the new data. And if you really generate for the graph based on this, the same will happen. Of course, I will have to change it into the cow values. Okay, and I make it like with the group. I do the grouping with the data, and I change it like by 0.5 something. The graph will look like this, and they're quite the same with the previous one. If you want to change it one more time, I would change it like 4.6 something, or if I want to change it like 0.4 something, the graph will look like this one. Okay, and I can all the time do the same, change it into the overlapping. Okay, and the graph will look like this. The only thing different now, the graph is actually, if I choose the same, they will look quite the same. But the only thing different now with the new data here, the mean and standard deviation. You see, check the average. They must be very close to 0. I'm sure about that. Okay, from Z2 into Z51, that's different to the previous data. But the standard, the mean value, oh my God, here, you don't understand what exactly this means, right? Just click on and just train it into the comma style. And yeah, that should be almost 0. A little bit smaller than 0, but they almost 0. Okay. Standard deviation, I'm pretty sure now they must be very close to 1. STDEV.P. Okay. Normal distribution. Exactly, man. Okay. You see it? Now the data from something having the mean values and the standard deviation will be very kind of different. Now they have been changed into the mean value equal to 0 and the standard deviation equal to 1. Ok. Thì cái normal distribution là cái gọi là normalization này nè. Ngoài trừ cách đó ra chúng ta còn có thể dùng một cái cách gọi là normal distribution. Normalize. Thầy nhớ là có một cái hàm gọi là hàm normalization. Normalization on Excel thì nó có một cái hàm gọi là hàm hình như là từ Excel 2021 2020 ấy, thì nó có cái công thức này. Không biết là ở bên máy của mấy đứa thì có không, gọi là hàm standardize. Hàm standardize return normal value này. Nếu như mà mọi người dùng giá trị từ giá trị x này, giá trị mean value, mọi người cứ bỏ lại giá trị bình thường của nó. Và tương tự như vậy với lại giá trị là standard deviation, giá trị bình thường của nó. Ok chưa? Thì mọi người tính ra cũng y hệt như vậy. Nếu mọi người dùng công thức là standardize. Được chưa? Giá trị cũng y hệt như cách hình thể tính bằng tính tay. Nhưng mà ý nghĩa của cái normal distribution, nếu như mà đối với standard normal distribution transformation này đó, hay người ta gọi là standardizing đó, standardization đó, hoặc là normalization đó, cái nào cũng được hết. Thì đó là từ một cái tập dữ liệu. Ví dụ như bạn tưởng tượng amount spending này. Amount spending này mà của hai người, một công ty thứ nhất. Cái này là cái tôi nói mọi người biết thêm nha, để mọi người biết thêm thôi, chứ thì thực sự là nếu như một công ty thứ nhất, được chưa? Công ty thứ hai cùng với lại cái amount spending này, nhưng mà amount spending này là của một cái người nào đó theo đơn vị là Việt Nam đồng, được chưa? Rồi, thế thì amount spending này của người ta so sánh hai cái tập dữ liệu, mà một tập dữ liệu nó là về sử dụng trong đô la, một cái tập dữ liệu thì nó lại dùng là Việt Nam đồng. Thế thì khi đó giả sử như thầy tính theo đơn vị đô la đúng không? Thì thực tế là thầy phải nhân ở đâu đó khoảng tầm 23.000 gì, đúng không? Đó, thì đây sẽ là cái giá trị của cái data của thầy nếu như thầy tính nó theo đơn vị là Việt Nam đồng. Hắn rất là nhiều dấu phẩy, hắn rất là phiền. Và thầy so sánh giữa cái amount spending của Việt Nam đồng với lại amount spending của đô la này thì thầy rất là khó nhìn, thầy khó thấy lắm. Rồi thầy ví dụ thầy tính mean value của tập dữ liệu này á, mà thầy tính là average đúng không, của amount spending này, thì mọi người thấy nó là một con số nó khác lắm so với giá trị mean của bên này theo tính theo đơn vị là theo đô la. Rồi tương tự như vậy giá trị bên này thì mình tính theo Việt Nam đồng. Và tương tự như vậy giá trị standard deviation, ok, STDEV.P đúng không, của cái tập dữ liệu data này cũng là cái amount spending này thôi, nhưng mà dùng với lại là Việt Nam đồng, thì nó là một con số hoàn toàn khác, rất khác so với lại những con số mà chúng ta có được ở đây đối với lại cái tập bên này. Được chưa? Nào, như vậy thì làm sao? Thì đến lúc đó thầy để mà đưa về cái tập dữ liệu này, thầy vẽ về thành một cái, ví dụ thầy vẽ cái đồ thị của hai thầy chẳng hạn, nó cũng sẽ rất là nhìn rất là khác. Nếu thầy thực sự thầy insert rồi thầy làm graph lại, thầy làm thật nhanh nhé. Thầy insert, thầy asserting, thầy cũng xuất cái dữ liệu đó trong trường hợp 2 vô cái tập dữ liệu ở đây. Rồi mọi người nhìn thấy thầy amount spending đây, thầy chỉnh lại nó thành ra là group nó lại, ngắn nó lại chút, group quá mất rồi, quá độ rồi. Group nó lại ví dụ như là 50.000. Ok chưa? Rồi kéo amount spending ở đây counting, thì mọi người nhìn thấy đây là một cái đồ thị graph này, cái graph của thầy này, Nó nhìn nó cũng khá giống với lại những cái đó nha, nhìn nó cũng khá giống đó, nhưng mà nó chưa hẳn là nó giống hệt với lại cái đồ thị bên trên đâu. Này nhìn này, đó cái đồ thị bên trên thì cái cách và các đơn vị ở đây nó khác nhau quá, cái unit nó ở đây nó rất là khác nhau. Vậy thì cách nào để mà xử lý nó? Đó thì standardizing nó chính là cách như vậy nha. Đưa nó về standard normal distribution bằng function này, nó sẽ giúp cho thầy standardize được chưa? Toàn bộ cái data của thầy với giá trị x values. Sorry. Standard dice. Ok. Data là giá trị x value, giá trị mean value là như vậy nè. Ok. Rồi giá trị standard deviation là như vậy này. Ok. Rồi. Bạn sẽ tính được hoàn toàn tương tự. Đây, amount spending. Nhưng mà lần này one more time đúng không? Là in the standard normal distribution. Và mọi người thấy này là hắn hoàn toàn gọi là totally identical với lại nếu như mà thầy tính bằng standardized normal distribution của US dollar. Mọi người hiểu ý thầy không? Và lúc bây giờ hai cái tập dữ liệu này nó giống nhau hoàn toàn nếu như standardized. Có hiểu ý thầy không? Là trong trường hợp standardizing là để chúng ta so sánh được những cái tập dữ liệu mà có các unit khác nhau. Ví dụ như thường nhất là những cái đồng tiền khác nhau. Người ta so sánh ví dụ như về GDP chẳng hạn. GDP của Việt Nam tính theo Việt Nam đồng. GDP của Mỹ thì tính theo là USD. GDP của China thì gọi là China Yuan. Đó. Hoặc là Nhật thì là Japanese Yen. Đó. Thì mấy những cái đồng tiền đó nó khác nhau. Nó tính làm cho cái GDP của mỗi nước nó khác nhau đó. Có nước nghe như Việt Nam đồng tới mấy triệu tỷ. Mình nếu như mà tính là Việt Nam mình mà tính theo đơn vị Việt Nam đồng á, và GDP á, là mình khoảng 5 triệu tỷ rồi. Trong khi Mỹ nếu tính theo đơn vị đô la thì nó chỉ là 21.000 tỷ đô thôi. Còn khi là mình là 5 triệu tỷ Việt Nam đồng, rõ ràng là không thể so sánh được với nhau. Thì ngoại trừ cách là sử dụng những cái công thức khó khăn bằng việc là dùng exchange rate đó, tức là tỷ giá hối đoái, thì chúng ta có thể dùng một cách thứ hai, đó là dùng standardizing để mà tính được là standard normal distribution. Ok. Rồi. That's why I talk about the standard normal distribution. Okay. And now let's do it and just do some kinds of like practice about how to measure the calculation. So we talk about pep John. Okay. The pep John sell the outer part and supply include a popular multi-grade motor oil. When a stock of this oil drop into 20 gallon, a replacement order in place. Tức là sao? Thầy mấy cái thằng này nó concerned about the sale being lost due to the stock out of the waiting for punishment order. Okay, so they wanted to see like if the oil drop less than 20 gallon or not. Có nhiều là kiểu như là công ty này thì nó chuyên cung cấp về các đồ phụ tùng trong xe hơi. Thì nếu như mà cái lượng mà oil để thay đổi ga cho oil là tức là cái loại dầu nhớt á, mà người ta dùng trên xe hơi đó, mà nếu như nó ít hơn 20 gallon ở trong cái kho thì nên phải đi fill, đúng không? Refill, replenishment oil e-play đó. Thì công ty này nó mới nhìn thấy là làm it has been determined that the demand during the replenishment lead time is normally distributed of the mean like 15 gallon and the standard deviation of the 6 gallon. Okay. The manager would like to know the probability of the stock out during the replenishment lead time. In the or other words, what is the probability that the demand during the lead time will exceed the 20 gallon. Ok. Tức là họ muốn xem thử là cái số lượng demand nếu như mà trong kho mình chỉ còn tới 20 gallon thôi, mà trong khi cái demand của những ông khách ông tới là họ còn đòi tới là trên 20 gallon, tức là mình không khả năng đáp ứng được, đúng không? Thế mình cần phải xác định là xem thử với những thông tin là mình biết rằng là cái demand của chuyện mà thay thế cái dầu ở trong cái tiệm á là thường nó có min là khoảng 15 gallon, và cái standard deviation là khoảng tầm 6 gallon, thì mình xem thử là trong thời điểm hiện tại bao nhiêu khả năng là mình sẽ không đáp ứng được, vì trong kho chỉ còn khoảng 20 gallon thôi. Mình hình dung rồi. Thầy sẽ save cái này. Let's go now. Gonna save this one. Okay. An example of the block, and let's go and do it with the number distribution. Okay. All right. And that's how to do it. So over here, they want to see like if they had the mean values. Okay. The mean values will be about 15. And the standard deviation of the data will be about 6 gallon. Now they want to see the probabilities that the x will be larger than 20. Okay. If I'm going to generate for that, according to this data, the mean values is 15, the standard deviation is about 6. So this is how it look like. It look like 20 will be over here, right? And it look like we have some kinds of probability that we cannot meet the demand, right? Okay. Now, let's do it. And how we can measure for the probabilities of x larger than 20. So according to the book, they use it all the time, like standard normal distribution, something they generate for, and they take a look into the what people call cumulative probabilities of standard normal distribution. This is what you can easily find on normal distribution table. If you wanna see it, how it look like, it could be also include in your book and also includes in whatever you can find. Okay, on like all the source of like online, they will be available here. They will be available here, and you guys can go and check it. And if you really want to use it, you're welcome, man. But I no longer want you to just spend time for this. I will just demonstrate everything and all the calculation like that on Excel and maybe also on the graph. So if you want to check it, okay, and you do it very easy, you can do it in 2 ways. First of all, you can go up there, you can use the normal distribution curve, and you just wanted to just answer for this question about what could be the probability of x larger than 20. Okay, all right. So I put in x will be equal to 20, and I want x larger than 20. This will be the point. Okay, so very easy. You put in like 20, and you want x. If you want it's like smaller than, you want to see like how it will be all the probabilities that will be smaller than the critical values of 20. So this all the areas that will be set in like the orange or black like this one. Okay, but the probabilities will be about, if you want to see the probabilities of x smaller than 20. Okay, so that will be 79.77%. Okay, but if you want to check it and you want to it's larger, and over here they ask for the probability that the demand will exceed 20 gallon, the x larger than 20. So you just change it, right? 20 larger, and that will be 20.23%. Okay, and they're the same, right? They the same. Actually, they will be 100%, and you minus it for the probability that's smaller than 20. So that will be the same with us. Okay. Okay, got it? Can you see it? How I demonstrate it all, right? Yeah. You see it all, right? Tất cả những cái bài này sẽ là những cái cách mà mấy bạn sẽ giải đối với lại các bài quiz trong bài này. Thầy ngày xưa người ta dùng á, là người ta dùng y như trong cuốn sách này, trong cái cuốn slide này, tức là người ta dùng nó bằng cách là người ta tra bảng một cái bảng gọi là normal distribution, và các bạn phải tính rất là dài, nhiều thứ lắm, tính đủ thứ hết trơn rồi bạn mới tra bảng mà bạn tính nó được cái con số này. Giờ chờ không cần thiết, được chưa? Không cần thiết. Thầy chỉ cần việc duy nhất của thầy là thầy bỏ vào trong cái hệ thống này thôi, là ông tự tính nó được dùng này. Cách thứ hai, the second way. You will use the function called the normal distribution, norm-dist function, okay? Norm-dist function, all right, in the Excel. And the norm-dist function, they will be normally norm.dist, and they also require for the x value. X value will be 20, mean values will be 15, standard deviation will be 6, cumulative must be true all the time, okay? And they generate something very interesting, right? I do it for you, but let's go to check it. How we gonna do it with this normal distribution? So normal distribution, we can also, this way will be just you put into the website, okay? And this way you put it into the PowerPoint Excel, sorry, for the Excel. And I recommend you guys just use it on Excel, okay? And how you gonna generate for that? Norm, okay? I want to say like probabilities of smaller than, of x smaller than 20. The thing will be like for Excel normal distribution, they cannot measure that larger than, but just like smaller than. Cái phần normal distribution function ở trong Excel nó hơi ngược ngạo xíu. Đó là nó không tính được giá trị lớn hơn, x lớn bao nhiêu, mà nó chỉ tính được giá trị x nhỏ hơn giá trị đó thôi. That's not that simple, okay? Now I do it. So I use the norm.dist, okay, function, and x values that should be 20, okay. Y, the mean values, that should be 15. The standard deviation will be equal to 6. Cumulative will be true because that should be cumulative distribution function. That should be 97. Okay, 0.88. 77, sorry. And with this, of course, we can also in reverse probability that x will be larger than 20. They, of course, will be equal to 100% minus 4. The probability that x will be smaller than 20, okay? So over here, that will be the same. Okay, 20 by 23, okay? And they do it, I don't know why they just score it down, but I'm pretty sure that I'm much more correct than them. Okay, I'm much more correct than the book. This should be 20 by 23, okay? Okay, or you can just make it some kind of like the approximate estimation. But with the Excel, those will be very correct. Okay, you got the point here, man. Got? Right. So the standard normal distribution, they do it and they measure that several times, and even they can do for the inverse function. So in this case, they want to ask for another question. If the manager of the auto zone, the auto shop, okay, the auto shop, he wanted to see the probability of the stock out during the furnishment lead time is no larger than 5%, no larger than 0.5, okay, that's 5%. That's what should be the real point be, okay? So they want to know what would be the values, what would be the value with the same function, but they want to see like what will be the probability that, okay, what will be the probability that here the probability larger than 5%, okay, it will be, okay, no more than 5%. That means all the data that's less than, okay, and we're gonna check it. 24.90 for 87, okay. So I can say the values that no more than 5% of stock out, okay, no more than 5% of stock out will be 24.87 gallon. Okay, so that means if you save in your stock like about 24.78 gallon, okay, you are pretty sure that you can meet almost like 95%. Okay, this is the same with the smaller 95%, right? With the 0.95, the same. Okay, this will be that mean just 95% of all the demand you can meet, and just very few of the other like 5%, they will be larger than this amount of the gallon of the oil you really want to stock in the stock. So that's the point. Thì cái giá trị mà về bằng cách là reverse này thì chúng ta sẽ sử dụng được cái cách để chúng ta tính ra được, ví dụ như xác suất là bấy nhiêu thì mình cần tính ra được cái giá trị point view này nó bằng bao nhiêu để xác suất nó hoặc là nhỏ hơn cái giá trị đó hoặc là nó lớn giá trị đó. Đây là một cái bài toán inverse. Okay, and you can do it the same with the norm inverse. Okay, norm inverse function. Okay, how we do it? Normal dot the inverse. Okay, and they ask for the probabilities. Probability now we have to put them into just wait a second. Okay, because that the probabilities of larger just top 5%, right? Up top will be like 0.0 or 5%. Okay, so that means probability of smaller than that values will be bottom will be 95%. Okay, so I've used the norm inverse. The norm inverse, remember, they are quite stupid in some way, I say, because they just can measure for all the probability smaller than the critical value, right? Remember, so we have to measure for probability of the bottom 95%. Okay, and probability now will be 95%. The mean values will be 15. One more time, the standard deviation 6, and that will be all. Okay, 24 by 20, 60, 86, the same, with all the same. Okay, we can measure them though in the different case of way, but please don't do it with the very cold method, old fashioned, like this way. They have been outdated, and you have to do it and make it super very hard to just measure it. Okay, so this will be the point I want to say. Yeah, I already demonstrate for you guys to use the normal distribution function and the normal inverse function. You can apply them at the same time. You can apply with the normal distribution curve to generate for the same result. And this will be all the content of the today's section about the normal distribution. That is not a very long part, but they quite conceptual, and I know that you guys got some trouble with that, but I hope that everything is clear enough. Is that okay?